Okay, 9.1 talks about savings alternatives. Okay, so you may save money in a bank account called a savings account. Okay, a pro of this is that you can access your money at any time. Okay, it's easy and convenient, so you can probably do it over the internet, many of them, or you can go into the bank and just simply transfer it over, or you can have an automatic transfer maybe on the first of every month. Okay, and also this account earns interests. Okay, the cons. So savings accounts, when you go into the bank, they make less interest than an actual formal investment. Okay, and there may be service charges on transactions if you choose to complete a transaction on that account. Okay, so what is a service charge? A service charge when you go to the bank is a fee charged by a financial institution for providing services. So the rule of thumb with a lot of financial institutions is that, like, for example, a bank or a credit union, is that putting money in is free, but taking money out costs you. Okay, so this is a rule of thumb. Also, just recently, I know that I've experienced that transfers between accounts, even though I'm keeping it in the same bank and just in another account, because I'm technically pulling out money from one account in order to put it into the other account, they're still charging. Okay, so when do you take out money? So when you use your debit card at the store, okay, so debit card, or when you withdraw money, at a bank machine, right? Or even if you had like an automatic payment. So automatic payment. So maybe your phone bill comes out automatically, and of course that's money coming out of your account. Okay, now any activity that occurs within account is called a transaction. So that's anything that happens on the account. So we can say we can call it a bill payment. What are some more examples? So service charge fees. So when the bank takes their $4 a month or their $10 a month for providing you a bank account. What other transactions? The debit card. Maybe you put your check in, so deposit the check. Okay, or if you work at McDonald's or if you work at Burger King and they put the check in, they put the money automatically in, that's still a transaction. So it's anything that occurs within an account. Okay, we're going to talk about interest. So let's recall the present value formula. So the present value of an investment. Okay? And what we're going to do is we're going to take a look at when we talk about 1 year, we talk about 52 weeks or 12 months, 365 days. These are all equivalent amounts of time. Okay, so sometimes when we get this present value formula, what we want to do is we only want to leave in our savings for maybe 8 months. So what we would do, first one's beautiful, 9 months. So what we would do is we can't just, and it's always in years. So what we would want to do is we want to put 9 over 12 years, right? So it's like 9 months out of 12 months. It's like 3/4 of a year. 3/4, and that's 0.75. If you just put that into your calculator, okay? Or if we talk about 26 weeks, if we want to put an investment in for 26 weeks, well, there's 52 weeks a year, so that would be half a year, for an example. 18 months, but months are measured in 12. There's 12 months a year. Oh, as a fraction, it's 1.5, but as a fraction, it'd be 3/2. It'd be a year and a half. Okay, 13 weeks, but every year there's 52 weeks. So that's 1/4. Keep going down, 90 days. This one gets a little bit more difficult because 365 is not a nice number. 0.24657, so 0.247. Let's leave it at 0.247. And I don't believe that this, 18 over 73 does reduce. Okay, and 120 days, well, there's 365 days a year again. So let's do 120 over 365. 24 over 73. 0.329. 0.329. Okay, so if we only want to leave our investment in for a fraction of that year, this is actually what we would sub in for the N. Okay, because again, N is measured in years, so we can have a fraction of a year. Okay, so let's see a full example. Jody receives $700 from her parents for her birthday, and she plans to buy a car by putting all of her birthday money into savings. So on July 1st, she opened a savings account and deposited $700. So that's what she started with. Okay, so we remember the principal would be $700. Okay, the account pays an annual interest rate of 0.5%, but this is compounded daily. Okay, so 0.5%. That's pretty much what you're going to get in the savings account. It's going to be very, very low. So 0.5% is actually going to be 0.005. Okay, and this is compounded daily. So what we'd have to do is we'd have to divide that by 365 days. Okay, so how much interest will Jody earn in 30 days? So we're going to solve the amount and then we'll solve for the interest after that. But we are going to multiply or use the exponent by the number of days, 30 over 365. Because remember, this right here, this 0.005, that's an annual interest rate. So we have to quote this N in also annual, okay? So if we did, and I'm happy with 3 decimals, okay? So this is 0.082 of a year, okay? So almost 10% of a year. And this is compounded daily, which is really ugly. 0.123413698. No, I'm going to keep that just to do this question. Okay, so let's find out the amount. So it's 1 plus I to the negative n. Oh, to the n, positive n. Okay, so let's see how much she made. She invested $700 at an interest rate of 1.123413698, and she left it in for almost 10% of a year. Okay, so if you go ahead and take your calculator and put that in, 700 times 1.12340 the exponent 0.082. I get the answer. This is terrible. 700.0007863. So she doesn't actually make almost any interest for leaving that in there for 1 month. So then you would take the amount, which is actually just $700, subtract 700, and she's not making anything. Okay, let's see about 6 months. So again, we're going to find the amount. She put in $700, and she's still earning that 0.005, which is 0.5%. And that's compounded daily. So every day she earns 0.000013698 interest. And now this time it's 183 days. Divide that by 365. Oops, 65. Okay, so let's go ahead and plug that in. So the amount is going to be the principal and 1.000013698. So the exponent, let's make this into 183 divided by 365 is going to be 0.5. So almost like half a year, right? 0.5. Yeah, and that's it. So we'll round to like the 2 or 3 decimals there. 5. We can put 501 if we want. So we're going to raise this to the exponent 0.501. Okay, so 700 times 1 decimal 1, 2, 3, 4, 13, 698. The exponent 0.501. And this time, again, even if we round it, she's not making any money. Okay, and that's quite normal for just a savings account. Like, it takes months to accumulate anything. So when you're going shopping for an account, really think about the savings account and how much you are making. Banks will have promotions where you'll get like 5% for a couple months, and then it's going to go back down to like 1% or even 0.5%. Okay, so let's talk about bank transactions. Okay, so Amy's bank charges $5.95 per month plus 75 cents for each additional transaction. Sorry, the $5.95 is up to 10 transactions. Determine the service charges deducted from Amy's account each month. So in July, she makes 16 transactions. Okay, so up to 10 is $5.95. So she will spend $5.95 no matter what. That's like a flat amount. It's linear, right? So it's a flat amount of $5.95. And then she has 6 transactions that she actually has to pay for individually. Okay, so we'll do 6 times 0.75. And that's going to be $4.50. Okay, 5, 10, 15. So in July, she's paying $10.45. Now in August, she made 24 transactions. So we know that she's going to pay no matter what, $5.95. And then 24, she gets those included 10, so she made 14 extra ones. Okay, so what's 14 times 0.75? $10.50. So she's going to be charged another $10.50. So she was charged $16.45. So something like this, what you'd want to do is you'd want to see if the bank would have an unlimited account, because you're definitely fluctuating between $10 and $16, which may be around the cost of an unlimited account. Okay? That's a lot. For right now, all students should have a student account where they should have unlimited transactions, or at least 25 transactions per month for free, like absolutely free, no base amount. But then when you get older, this is something that you definitely have to think about.